Okay, this is really new for me. So you enter podium and everyone becomes quiet. So thank you all. So welcome in B30. My name is Marko Hekkert, Director of PBL. We do this in English because our keynote speaker doesn't speak Dutch. So it's an all-English event for a change. We don't do this very regularly at PBL. And it's a special occasion. So we call this the Academia lecture. And there's a special reason for this. So at PBL, I think we are really specialized in the science policy interface. And normally we bring our own knowledge to policy and politics. But we also try to integrate all kind of knowledge that's produced in knowledge ecosystems to this square kilometer in The Hague. And this is also one of the instruments that we use to bring really top-notch, state-of-the-art knowledge to people who make decisions or design policies. We do this once a year, and this year, we have an extremely well-known, very good speaker. I will introduce him in a minute. So I'm very happy that so many of you showed up here. So as you can see, we have a full house, and there are also quite some people online. So this year, the Academia lecture, the topic is the food system within planetary boundaries. And we chose this topic really on purpose. So we all know that the food system is a very important topic in the Netherlands. The Netherlands is we are very proud to be the second exporter of agricultural commodities worldwide for such a small country. Well, as you have seen also in the recent years, there's a lot to do about our production system of producing agricultural commodities. We have the so-called nitrogen crisis in the Netherlands, and we see that the government is coming up with all kinds of ideas and plans, but they're very focused on the production side of the agricultural system. So it's directed at farmers and how to produce food. There's much less attention to the consumption side, to our dietary patterns. And also in the most recent report on this topic that we wrote, it was a scenario study to bring agriculture and nature in more balance. We also focused much more on the production side. So what type of changes are needed there to bring nature and agriculture more in harmony. And also we did not we limited ourselves, not including all kind of dietary changes. And this is really the topic of today. So we try to correct our omissions a bit. So one important report that came out recently, it's the Eat Lancet Commission report, and it brings together global experts in food, health and sustainability to define what a healthy diet actually is, but also assess its environmental benefits. And last year, the second version of this report was published, and this work of this commission was led by Johan Rockström, and he is our main speaker of today. And I'm sure many of you came all the way to The Hague to hear him talk. So we are very happy and very glad that Johan is willing to participate in this Academy lecture series to present the work of this Eat Lancet Commission. I will introduce Johan a bit more in a second, but first let me go through the program. So first Johan will do his presentation of about 45 minutes. And then we asked two experts to reflect on his presentation, which are Professor Marianne Geleijnse and Professor Hanna van Zanten, both from the Netherlands, so they can also interpret this global work on the specific situation in the Netherlands. And after that, we have a discussion with all of us, so you can raise questions, and I will bring them all here on this stage, and then we can try to answer your question. And also Detlef van Vuuren will join, and he's my PBL colleague, and together with other colleagues, he also participated in this Eat Lancet report. So then towards Johan. So Johan Rockström, he's the director of the Potsdam Instituut for Climate Impact Research. Johan is internationally recognized for his research on global sustainability issues, and particularly the planetary boundaries framework. In 2009, he led the paper published in Nature that introduced this framework. It became extremely famous and is now used as a key starting point in many sustainability assessments. And since 2009, several updates of the framework have been published, among others by the Earth Commission, which is also coordinated by Johan. For the past 10 years, he also led the Eat Lancet Commission, a collaboration between food and sustainability science focused on defining a healthy diet and its potential environmental benefits. So that's about you. Well, I'm very happy that you're here. It's also funny with your last name. I always call you a rock star scientist, so it's already what's in the name. So the stage is all yours for 45 minutes, and we're very eager to hear your presentation.
Thanks, Marko. It's a privilege to be here. What I want to do over the next 45 minutes is actually to widen the food system agenda, also to give you an update on what is concerning us, particularly today when it comes to the stability and the resilience of the planet, that we're so deep into the Anthropocene that we're today, unfortunately, forced to consider the real risk of destabilizing the entire Earth system, and that the food system transition is what I would argue being the most important and most urgent lever that needs to change very fast to bring us back within a planet that can remain within the range of variability that we've been privileged to be in since we went through the Neolithic Revolution and became domesticated, sedentary inhabitants on planet Earth some 8,000 years ago through the Neolithic. Now, you know the evidence here. It starts with the Great Acceleration, which proves today beyond any doubt that we are deep into the Anthropocene, where we are the dominating force on planet Earth. So the fact that we've transformed 50% of the land area, that we're today withdrawing 70% of fresh water, that we're today overloading the biosphere with reactive nitrogen and phosphorus, are all shown on these graphs. Up until 1950, we have incremental impacts, and then off we go in this exponential rise. And today we are on top of these curves, and unfortunately, we're not bending them yet. What concerns us really today, which connects very tightly with the food system, is the fact that for the first time we're starting to see something really worrying, which is a tendency of accelerated rate of warming on planet Earth over the last decade. Now, this is something that really worries us because it could be the first signs of a planet losing resilience, a planet losing buffering capacity of being able to dampen the heat injection, the Earth's energy imbalance caused by our unsustainable exploitation of ecosystems through agriculture, how we produce food, but also how we're loading greenhouse gases from nitrogen oxide, methane, and carbon dioxide and non-CO2 gases. Now, you may have seen last week, a paper was published with one lead author from my institute, Stefan Rahmstorff, statistically verifying this rate change. This is really concerning. It shows that we today can say with high degree of confidence that we are actually moving into a state where the planet is showing its first signs of losing its resilience. And you may have seen, or perhaps you haven't, but yesterday Jim Hansen, one of the leading scientists on the whole climate science and Earth energy imbalance, also puts out a new paper confirming what this implies, which is that the climate sensitivity on planet Earth is therefore very likely going down, meaning that a doubling of carbon dioxide may not lead to what we've thought for the past 50 years to a 3 degrees Celsius of average temperature rise, but rather 4, potentially even 5 degrees Celsius. Dear friends, if this is correct, this would mean that all climate policy crashes, all the climate budgets crashes. It means that we are in such a much more serious urgency point in terms of the pace by which we have to deviate away from danger, where again, the transformation of the global food system and the energy transition becomes even more urgently required to focus on. Now, the reason why we are having this concern is that the cause behind this rate change in warming can come from two sources. One is the one that we tend to focus most on, which is forcing, which is we emit more greenhouse gases or we change air pollutants, which is essentially the loading of nitrous oxide or methane or carbon dioxide, but also changes in air pollutants like sulfates and nitrates. That is, as far as we understand today, and I say as far as we understand today because the debate is on, the jury is still out. Scientifically, this is being worked upon, but roughly half of the rate change is, as far as we understand today, caused by forcing, changes in forcing. But it's not that we are drastically increasing forcing because of emitting greenhouse gases. It's more likely the paradox that we're getting rid of air pollutants, which cools the planet when we pollute the air, but actually warms the planet very rapidly when we get rid of air pollutants. That's one half of, or likely one half of this force, of this increased rate in warming. The other half is changes in feedbacks. And that is what I want to focus on, because that is what relates predominantly on our investments in resilient and sustainable food systems, namely the response of the planet. Is it so that we warm the planet and it's causing more vapor, more clouds that net warm the planet more fast than we had expected, which then also translates to more extreme precipitation events, but also what relates most closely to the global agricultural system, namely the carbon uptake in the land-based biosphere. We see the first signs of decline in carbon uptake capacity on land, not yet in the ocean, but this is very likely one of the factors that causes the planet to warm faster than we had expected. Permafrost thawing increasing, ocean heat flows, as you probably have followed, are also showing signs of instability, not yet of releasing heat, but the best projections now is that we may be moving into one more El Niño event, potentially already next year. And finally, the risks of crossing tipping points, where we are continuously studying these risks. If feedbacks are causing the rate change, then it's more permanent. Then we are more in a kind of a, from our timelines, more irreversible risk of causing sensitivity shifts in the Earth system, meaning a planet losing its health and strength, which again causes us to have to move much faster. What's the evidence behind this? Well, we know that so far, what you see here to the left, or what I would say on this screen, is the best summary of the two sources of resilience of the planet that we measure most prominently. On the left-hand side is the heat uptake. And again, a reminder, 90% of the heat caused by our fossil fuel burning, unsustainable land use change is not in the atmosphere. It's not what has caused the soon 1.5 degrees Celsius of warming, which we now inevitably will be breaching within the next 3 to 5 years in a more permanent way. So I'll come back to that. We're moving into an overshoot stage. 90% of the heat from our unsustainable injection of heat into the Earth system is in the ocean. 4% is used to melt ice, so the accelerated melting of ice sheets, and 5% is absorbed in the biosphere, in the soil systems. There's only 1% which is in the atmosphere, causing the climate crisis that we're increasingly experiencing with all the extreme events from fires, droughts, heat waves, floods, human-reinforced storms. So that's one resilience factor, the fact that a healthy planet is able to buffer over 90%, actually 99%, of the heat injection. The energy imbalance lies essentially in the ocean. The planet is a thermostat. The second part is what you see on the right-hand side here, which is the one that relates most closely to the global food system in terms of its service to humanity, which is the carbon cycle. You see above the zero line the hockey stick of emissions in red, and land use change, where agriculture expansion is the dominating one in yellow. Is it the area under this curve that has caused this Earth energy imbalance and climate crisis? The answer is no. It's the green part is the ocean uptake, and the lower green is the land uptake, which is remarkable because what you see here is that the more we've been disturbing the planet, the more the planet's biogeophysical system has been helping us. And this is exactly what we're seeing. It's only this residual blue part here which is remaining in the atmosphere, causing the heat imbalance and causing the climate crisis as we know it. This number is roughly 25% in the ocean, 25% on land, all the way up until the point, I think you can even sense it when you look, even without statistics, that it seems to be leveling out on land. And that's exactly what we're seeing, a tendency of lowered carbon uptake on ecosystems on land. And this is related to unsustainable land management, agriculture, but also the first signs of intact nature reducing its carbon uptake. So the Brazilian part of the Amazon rainforest is already now a net source rather than a sink, but we see it also in temperate forest and boreal forest regions. So this is not a tipping point. It's not a planet that suddenly is kind of falling over, but it's the first signs of a planet showing weakness, showing a tendency of being at a saturation point in terms of the pressures we pose. And this is why the urgency of the food system becomes so pertinent to focus on. So that's one part, the pressure. The reason why we need to have a food system that develops within a safe operating space on a stable planet is not only related to these first signs of a shaking planet, it's also that we have so much evidence of the planet we depend on. And the planet we depend on is today, I would argue, quite well scientifically verified to be the Holocene. The Holocene, as you know, is the stable interglacial that we entered after leaving the last ice age some 18,000 years ago. I call this today the corridor of life. And we have so much paleoclimatic support for this to be the reference point on the planet we depend on, which is fundamental in the food system transition because this is the measuring point we use as a reference to quantify a safe operating space for all the Earth system processes that regulates the stability of the planet. If we're destabilizing the planet and we depend on a stable planet, we need to know what is that stable planet. And here you have it on the screen. Now, this shows the last 400,000 years. What you see on the y-axis here is global mean surface temperature. The zero line is the pre-industrial 14 degrees Celsius mean temperature on Earth. And if you look at the middle plate first, we leave the last ice age 18,000 years ago, minus 5 degrees Celsius on planet Earth, and we enter this extraordinarily stable Holocene, and we've barely entered it, and we go through the Neolithic Revolution. So this is proof in itself that we go from being a few million hunters and gatherers in the Ice Age. We've lived on planet Earth for 250,000 years, so we've had 1, 2 ice ages and 2 interglacials. That's our presence as fully modern, physically and intellectual modern humans on planet Earth. But it isn't until we enter this extraordinarily stable Holocene interglacial that we go from being hunters and gatherers to domesticate animals and plants. We become farmers, we settle down in villages, and off we go in the civilizational journey that takes us essentially to The Hague, the 23rd of March in 2026. It is a very, very clear journey between stability of the planet and human ingenuity and development. I call this today the corridor of life. This corridor of life is a range that we increasingly understand. Actually, it's quite extraordinary. It's a 14 degrees Celsius planet plus minus 0.5 degrees Celsius. We understand increasingly that biomes, hydrological cycle, all the ranges of the carbon cycle, the methane cycle, permafrost, ice sheets, they essentially established themselves in the Holocene. We've had the genetic diversity and the functions have been around often for millions, if not hundreds of millions of years, but it's in the Holocene that everything that we cherish, that we depend on, that we use as a foundation for our global food system is established there. The rainy seasons, the fact that temperatures go above 15 degrees Celsius in May and stay above 15 degrees Celsius until September, so you can have a 120-day growing season, establishes itself in the Holocene. It was not there outside of the Holocene. So this is what we're risking today, because in the right-hand corner here you see the journey we're following in the Anthropocene. We're heading towards 2.5 degrees Celsius of warming, 2.5, 2.6 by the end of this century. We can't exclude that we exceed even 3 degrees Celsius. If we were to go there in the next 50 years, we would be winding back the climate clock, not 2 million, but 3 million years. We would go outside of the Quaternary. So I would have to basically push this whole line back through the entire Quaternary to find an equivalent temperature on Earth. This is why it's not a surprise that you therefore hear scientists being more clear to define this pathway as a path to disaster. A path to disaster. There's no scientific evidence that you can support the world as we know it on a planet where we're winding back the living conditions, the conditions for agriculture and food production, outside of the Quaternary. Okay? It's only in the last 1 million years in the Pleistocene that we've had this dance between the 100,000-year-long ice ages and the 15 to 30,000 year interglacials. And it's only in the last two last glacial cycles that we've existed on planet Earth as humans. And now we're shooting ourselves outside of this range in a way that will bring us very, very far away from anything that we know. So this is why we use the Holocene as the measuring point for defining the safe operating space on planet Earth. And finally, which is the third and final piece of evidence that we bring into the planetary boundaries to define the safe space, which will then bring us to the food system definition, which is that tipping points are hardwired. We now understand that large biophysical systems on Earth have multiple stable states, and they regulate and contribute to regulate the state of the climate system by being dominated by negative feedbacks. Negative feedbacks meaning dampening feedbacks, okay? A stable ice sheet reflecting 90% incoming radiative forcing from the sun back to space. That's a negative feedback. A melted ice sheet is much darker, absorbs more heat, and becomes a self-amplifying feedback. Here you have the 16 climate tipping element systems we have been mapping. They're in the Intergovernmental Panel on Climate Change. They're across the entire planet. 6 of them are in the Arctic, connected through the AMOC, the Gulf Stream, overturning circulation system in North Atlantic with the Amazon rainforest. 3 of them are down in Antarctica, and one, of course, victim number 1, largely scientifically, which is the tropical coral reef systems. These are all, and I show this to you because I think it's critical to understand that these are spread across the entire planet, and whether we are in The Hague or in Beijing, we all depend on them. They are the new commons. They are the system that we all depend on for the stability on planet Earth. Here you have the breakthrough after the last IPCC assessment, which is that we in 2022 were able for the first time, building on published research, to quantify the temperature levels at which they are at risk of crossing their thresholds. I won't go through this in detail. You see the uncertainty range, which is these burning embers in red. The small dots are the median levels. I just want you to focus on the top 6, showing that already between 1 and 2 degrees Celsius, it's likely that we trigger a tipping point for big systems like the Greenland ice sheet and the West Antarctic ice sheet. I've also put a marker, as you see, on the AMOC and on the Amazon rainforest, because these are 2 systems, as you see, with huge uncertainty ranges, with temperature levels exceeding 3 degrees Celsius of risk of tipping. But the latest science shows that we've mistaken ourselves, because when they interact across planetary boundaries, in particular with agricultural systems, they may be tipping earlier. And I'll show you the evidence behind this. What this implies also, the science on tipping points, and where we're moving today, is that we're heading towards overshoot. And I think this is something we also need to bring with us when we look at the food system transition, that most likely we are within the next 3 to 5 years going to breach the 1.5 degrees Celsius line, which puts us at risk of crossing tipping points. And this blue line here, which is the IPCC scenarios of basically limiting overshoot and bringing us back under 1.5 degrees Celsius by the end of this century, we conclude today is no longer possible. That because we've not bent the curve of emissions yet, we are unfortunately at a point where those blue, that limited overshoot pathway is not possible. That the best we can do is following this magenta pathway, which is minimizing overshoot, but unfortunately accepting that we will, at best, peak somewhere around 1.7, 1.8 degrees Celsius before coming back under 1.5 degrees Celsius. Now, the reason I show you this here in this transition phase is that the big question, of course, is what brings us back? What is it that can hold us back from just continuing up to that 2.5, 2.6, 3 degrees Celsius? Well, it is largely the global food system transition. It's about bringing us back to secure that the Earth system can buffer and dampen and remove carbon through ocean and natural systems on land. But it also requires decarbonizing the global energy system. Unfortunately, the overshoot will mean more extreme events. So what I talked about earlier, about extreme events being one of those key factors that we're seeing already today, I can say with very high degree of certainty that these will continue, like the Los Angeles fires and the Valencia floods. We will see for every 1/10 of a degree of increased warming, we'll have more extreme events. I mentioned the AMOC. This is one of these systems that IPCC concludes has low likelihood of a shutdown with low confidence this century. Science since the IPCC shows that we can no longer consider this to be a low likelihood event. The AMOC regulates the entire overturning of heat in the North Atlantic, but it also therefore regulates the rainfall systems over the Amazon and West Africa. So it has very strong connections with the food system. If it would collapse, which we know it has done geologically, it has actually it has a switch on-off. We understand this fairly well. It would lead to massive cooling, as you see on this map, in the Arctic region, but it would also lead to a net warming planetary-wise and changes in rainfall patterns. So it would be essentially a change that would be unacceptable at the global level. And today, the latest science, led by scholars in this country from Utrecht University, showing that even at current emissions, the intermediate level you see here, there's an estimated 37% likelihood of a significant slowdown of the AMOC within the next 50 to 75 years. So this just shows again that as science advances, we have to be really careful about not allowing these occurrences to happen. The Amazon rainforest, we put the threshold really high at 3 to 5 degrees Celsius. We've been proven wrong there, because if we continue transforming biodiversity and forest systems by agriculture expansion, largely beef production and then soya bean production as feed for livestock, we are rather very likely to be having to change the threshold level down to 1 to 2 degrees Celsius if we continue losing more than 25% of the canopy cover. And the Amazon rainforest has today lost 17% of its canopy cover, and we are today approaching 1.5 degrees Celsius. So again, showing again that how incredibly interactive and important it is for us to understand it's not only about climate physics, it's also about how we manage the biosphere, agriculture, and how we are approaching these unacceptable risks. This is why, to close this chapter, we've concluded that in a paper very recently led by Bill Ripple at Oregon State University, that we can no longer exclude that we are approaching a point where we may see irreversible changes to the planet. That is why we need a planetary boundary framework. So this is what brings us to this point. And this is, I think, important when then looking into the food system transition, that what really makes us conclude that we now have to be stewards of the planet, when we say that we are having to address planetary scale risks. This is the journey that takes us there. The Anthropocene pressures, the Holocene as our only state we know can support us, and the tipping points are not only real, they are approaching fast. Now, the beauty here scientifically is that we have 15 years of science under our belt to advance the planetary boundary framework, where we have identified the Earth system processes that regulates the state of the planet and the functioning of the Earth system. Those are the 9 planetary boundary systems. And we've then identified 13 control variables, data points, where we can map out science to quantify safe boundary levels for these 9, and that is the green space you see here. There is uncertainty in science, that's the yellow range you see here, but the further you move away from the green part, the deeper you go into the high-risk red zone. And what you see here is the 2023 update of the science, which shows, no, I can see on the screen it is the 2025 update, in fact. It shows that 7 of the 9 planetary boundaries are exceeded. The 7th one was concluded in October 2025 in our latest update, which is ocean acidification. So what this shows, or let's say this verifies the story, the scientific story I've given you so far, that we have a planet where we're not only causing a climate forcing by breaching the climate boundary, which is the one you see on the top here, but we're also undermining the biosphere. We're undermining biodiversity, fresh water, nitrogen, phosphorus, land, air pollutants, and now also ocean stability, which is all dominated by the global food system. So we're doing a kind of a double mistake. We have a climate crisis, and when you have a climate crisis due to primarily fossil fuel burning, but also unsustainable land management, you would have wished to at least have a strong planet to buffer that stress. But we are kind of kicking the planet and at the same time pushing her from two sides, and this is the unfortunate reality. This slide I'll spend another 30 minutes to describe now. That's okay? This is just to give you the confidence that there's a lot of science behind the 9 planetary boundaries, all the control variables. We've been quantifying them. It's ongoing work. There's over 1,500 peer-reviewed papers now on planetary boundary science, and it's critically massaged and turned, and we're continuously updating this to a point where we actually now recognizing that we cannot do these updates every 7th year. We have to do it every year. And that's why we've launched something called the Planetary Health Checks. This is the 2025 Health Check. If you Google Planetary Health Check, you'll get a fantastic, actually 140-page summary of all this work. We have actually used now an analogy of bringing planet Earth to the doctor and having a full screening each year. If you have a sick patient, you don't want to go to the doctor every 7th year. You want to actually meet your doctor a bit more frequently. So now we take her to the doctor every year. And here are the blood sample tests that kind of verify the 7 boundaries being breached. You see the yellow part there, which is the uncertainty range in science. That's what I call the danger zone. Things can go wrong, but it's still in the uncertainty range in science. And we have also, for the first time, dared to do what you see on the screen now, which is by combining statistics across all the 13 control variables, but also expert elicitation to say what's our verdict on the patient as a whole. We have all these tests on all these organs of the planet, and what's the verdict of the planet? And we place the planet outside of the green space. We are in danger, but not yet outside of that yellow danger zone, which suggests that the window is still open to turn this around. So the food system transition still has a very, very strong, legitimate and an urgent need, because that can bring us potentially back to a safe space. That's the big question we posed with the Eat Lancet Commission, where we for the first time gathered public health scientists, agricultural sustainability scientists, and planetary boundary researchers to ask the question, can we produce healthy food within sustainable food systems? And if we do that in a scientific quantification, how far can that bring us in terms of taking us back within the safe operating space of a stable and resilient planet? So that is what we did in the Eat Lancet Commission report. As Marko pointed out, this is the second Eat Lancet Commission report, so if you promise to don't quote me here, our kind of internal vision is to create an IPCC for food. So we're hoping already that this will become a third Eat Lancet Commission report as well, because we think that the world needs this continuous update on healthy diets from sustainable food systems. It has a whole set of key findings. Number one is what is, of course, known, not surprising in this room, that food systems is the primary driver to transgression of 5 of the planetary boundaries. I'll come back to that. 30% of greenhouse gas emissions. We also have evidence that shifting towards healthy diets, according to the latest science, could reduce premature deaths of up to 15 million people per year. This is, by the way, a higher number than the numbers of people that lost their lives during the COVID pandemic on an annual basis. We also know that justice is a fundamental issue. Only 1% of the world population is estimated to live geographically in regions where there's adequate food in terms of nutrition and health, and in terms of sustainable, meaning being within sustainable planetary boundaries. And we also have, from the Food System Economics Commission work that is close to the Eat-Lancet Commission, evidence that the global food system is actually on a total a kind of a negative if you factor in health costs and the most basic environmental cost. The market value of the global food system is roughly $10 trillion per year, but the real cost of the food system is estimated to $15 trillion per year. So not a very good deal if you think of what it gives in terms of human health, in terms of planetary risks, and in terms of money in the global economy. Now, what is the Eat-Lancet Commission 2.0 findings on healthy diets? Well, to begin with, it's really critical here to just remind that what we did here, we separated health science from the planetary boundary or food sustainability science. So what I show you now is based only on synthesizing what gives the best outcomes for health, not considering environment. And you have the numbers here, so everything is quantified, the different food groups in the best possible human health-related diet. We call this the planetary health diet. It includes significantly higher degrees of vegetables, nuts, and legumes, with up to 5 servings a year per day of vegetables, but massive increase, significant increase in nuts. Not a vegan or vegetarian diet, it's a flexitarian diet with significant reductions in animal protein intake. You see the summary here of up to 150 grams per person per week of red meat, 2 servings a week per person white meat, and 2 servings per person per week of fish. So it's not suggesting a total kind of abandoning of animal-based protein, but the health research indicating that a significant reduction gives the best health outcomes. This is the plate that summarizes the planetary health diet. Half of the plate being plant-based sources, whole grain, nuts, legumes, basically doing 2/3 of the intake. It is unsaturated fats, still some dairy, but reductions clearly. If you look at the different types of diets, it has large ranges for each of the food groups, so you can actually combine this in different ways. So even though the average is most close to a flexitarian diet, which you see to the furthest left here, you could think of vegetarian and vegan options, but then you have to compensate for certain parts of the food groups if you reduce to 0 on the animal-based protein intakes. We have made estimates what this implies globally, which shows that globally vegetables is actually having a roughly average intake equivalent to the planetary health diet, with many parts of the world, as you see, under-consuming, while Asia is over-consuming. Fruits is something that needs to increase overall, but the big drama is, of course, on nuts and a reduction in dairy products, and look at meat. Here we have, of course, why this is conceived as being a really debated issue, not least in our parts of the world, with a drastic overconsumption in North America, Latin America, and Europe. But look at, for example, South Asia. It's not as if this is a very dramatic step for some parts of the world. We've also developed a planetary health diet index, showing that we can have up to 30% reduction in diet-related diseases if you have 100% adoption of the planetary health diet. So strong evidence of benefits for us personally. And what we did a mistake in the first Eat-Lancet Commission report, it was perceived as if we were imposing a kind of one monolithic diet on people, which of course is not the case. It gives a scientific-based frame in which there is a very, very high degree of flexibility and diversity. So we've been really mapping traditional diets in different parts of the world, and it's interesting that traditional diets tend to be closer to the planetary health diet. And then we went into the sustainability part separately, and we used the planetary boundary framework in this analysis, quantifying for all the planetary boundaries what is the food system share of the planetary boundaries? So think of it as, so for the climate wedge or the biodiversity wedge or nitrogen wedge, what's the responsibility of the food system in terms of the global share of that boundary? Quantifying all of those. And here you have the graph I showed earlier, the planetary boundaries at the planetary scale, the transgression level. And here's the finding of the responsibility of the food system. And I can tell you, it surprised even us in the Atlantic Commission work when we saw this. That is a very powerful reminder of the importance of the food system transition. The single largest emitter of greenhouse gases, by far the largest withdrawer of blue water, major consumer of green water, the number one cause for loss of biosphere integrity, a fundamental cause in terms of land system change. Nitrogen, phosphorus, I don't have to speak to Dutch colleagues about the challenges there. Significant impacts on pesticides. This is a very strong scientific support for the food system transition being one of the most important levers for a safe landing within the safe operating space. We took this into the first large model into comparison program, and I'm really proud to say that we collaborated very closely with the image team here at PBL on this, looking at what we eat, how do we produce it, food waste, but also combining it with the energy transition. Admittedly, 10 models with a lot of kind of diversity in the overall results, but they showed very clearly the need for a transition with reduced livestock production, an increase in vegetable, nuts, fruit, and a fundamental shift towards sustainable intensification. And here you have a high-level summary of this major modeling exercise. So if we continue eating as today and project that into up until 2050, this is the results if you include the boundaries we could include in this case on land, greenhouse gases, blue water being irrigation water, nitrogen, and phosphorus. And you see we just continue deeper and deeper into the red. If we transition into healthy food, this is the result. It would bring us significantly back. Just by thinking about our own health, we would actually have a very significant contribution towards removing or moving back towards a safe space. But as you see, it wouldn't take us all the way. It's only when we combine this also with mitigation, also with an energy transition, that we truly can bring us into a safe space. So what you see here is eating healthy food, reducing food loss and waste with 30%, transitioning towards sustainable agricultural production practices, which are well established and known, so there's no kind of utopian or fantasy assessments here, plus getting off diesel and petrol in the value chain of the agricultural system. That is what is required. It's a sustainability transition, indeed, but interestingly, it has resilience building aspects and health building aspects. It would mean a reduction in ruminant meat, which would free up land and reduce pressure on natural ecosystems, a 22% reduction in dairy. Non-ruminant animals would also decrease. Fish in this assessment would slightly increase. Very likely aquaculture, not related to wild fish. We did a justice analysis also for the first time in the Eat Lancet Commission work, assessing the social foundation in terms of affordability and in terms of minimum access to nutritious food. And you see that in the y-axis of unmet to met. On the y-axis here is the planetary boundaries in terms of safety, meaning what are the regions in the world that meets the safe planetary boundaries or food system boundaries, and the upper part is unsafe. And what you see is that in the upper right-hand corner you have the rich parts of the world that live largely in a nutritious world in terms of having access to healthy food if we want to eat it, but we're largely doing it at the expense of the planet with unsafe production systems. But then you have in the lower left-hand corner those who are not impacting on the planetary boundaries, but are nutritionally really below any levels of justice. And it's only 1% of the world population that is in this desired right-hand corner, which is both safe and just. So that was one of the findings we have, that it's a long journey to move forwards in terms of both safety and justice. Here you have also the quantifications. I just showed this, that we have the journeys we need to follow in terms of transitioning on emissions, on land use, on sugar, legume, on affordability transitions, water-related. And let me then also, so that's all I wanted to say on the food system. I just want to give you quickly then, before ending here, an update also on what I would argue to be the twin or second large transition that we have to urgently embark on, which is the energy transition. So food and energy, in my view, hang together as the two largest and most important levers we need to focus on in the next years ahead. So the global carbon budget is largely consumed. As you know, we have only 130 gigatons of carbon dioxide remaining to have a chance of limiting that overshoot period that I showed you earlier. This is the latest post-IPCC scenarios that we've run, at least at PIC, the REMIND model together with climate analytics, showing that we have not made any progress. So we are, unfortunately, on this curve here where we've not bent the global curve of emissions yet. Just look at this curve that we need to follow. It's actually a 10% per year reduction of emissions to reach zero by 2050. This can give us a chance of limiting that overshoot to 1.7 degrees Celsius and bringing us back under 1.5 by the end of this century. But it requires that we phase out coal by 2040, gas by 2050, and oil by 2060. We simply need to transition very, very fast to have a chance of succeeding. That is why we at the COP30 in Belém recently, when the Brazilian presidency tried really to launch the roadmaps on accelerating the phase out on fossil fuels, they failed in the negotiations. The Netherlands and Colombia will be hosting this meeting in Santa Marta end of April to really gather the coalition of the willing to start transitioning away from fossil fuels. We held a press conference. This is a press conference I hosted together with Professor Carlos Nobre at the University of São Paulo, one of the leading scientists on the Amazon rainforest, to suggest establishment of a science panel for the global energy transition. We will now set this up, and we will be supporting any country that wants to accelerate the phase out of fossil fuels in the years to come. So I just want to share with you that the food system transition and the energy transition are both areas that we scientifically today really try to support as far as we ever can, because it all boils down to this. It all boils down to keeping these global commons intact. And irrespective of where we live on planet Earth, we are putting these at risk, and if they cross their thresholds, they will move from helping us to becoming from friends to foe, and therefore also making it even more difficult for us to hand over to our children a livable planet on this beautiful Earth system that we all depend on. And with that, I hand back to you, Marko. Thanks a lot.
Yeah. Marianne is full professor in nutrition and cardiovascular disease at Wageningen University and research. And since the beginning of this year, she was one of the vice chairs of the Health Council of the Netherlands, a position which you held for 8 years. In this position, you were also, amongst others, involved in the revision of the Dutch dietary guidelines and in the advice of a healthy protein transition. So you have the opportunity to reflect first, and then we continue.
Can I have my slides? Yes, thank you so much. I first want to congratulate Johan Rockström and the entire Eat Lancet team for this huge effort. And it's very inspiring also to me as a nutritionist to use this as a basis for future dietary projections. So I have no conflicts of interest regarding this presentation. And as you told, I'm also responsible, so to say, with many others for the Dutch dietary guidelines. So the first thing I did when I saw Eat Lancet 2.0 is to check whether the dietary guidelines in the Netherlands are in line with these planetary boundaries. And then I first start looking at the methodology, and I see that we did quite a lot in common. So both the dietary guidelines in the Netherlands and the planetary health diet are primarily driven by the diet-disease relationships. So both diets will really help to reduce the amount of cardiovascular disease, cancers, obesity, and other chronic diseases in the populations. But we both take the context of the environment into account. And luckily, there's a lot of overlap between what's good for human health and what's good for the planet. So these align quite well, and both tell the story that we should move from animal-based diets more to the direction of plant-based diets. So there's a lot of alignment. The Dutch Dietary Guidelines update was released in December last year and is now being translated into the so-called Wheel of Five by the Voedingscentrum, Dutch Nutrition Center, and that will be released in a couple of weeks, so that's exciting. So the Dutch Dietary Guidelines luckily fall within the ranges as defined by Eat-Lancet, so the planetary health diet. But I want to dive deeper into a few aspects that I think are worthy to mention here. And the first one is the meat challenge. So we must cut down the red meat intake in the Netherlands, and not a little bit, quite a lot. So the advice from the Health Council is a max of 200 grams of red meat, though that's specifically for red meat, beef, pork, lamb, and that's below 30 grams a day. That's just in line with the planetary health diet, with the upper range of 30 grams a day. But the Dutch eat on average 70 grams a day of red meat. So we must halve the red meat intake in the Netherlands. So that's quite a challenge. Not as big as a challenge as in the USA or some other countries, but still it is only 2 meatballs a week. Huh? And planetary health diet is 1 meatball a week, but that causes quite some concern with many Dutch meat consumers. Then we have the other challenge, the legumes challenge. We call them pulses in our advice. These are the dried seeds of the legumes, so the beans, lentils, chickpeas, split beans. Interestingly, the bruine boon, the brown bean, is part of the traditional Dutch diet. So in fact, we should maybe go back to the poor man's diet in the Netherlands, which is also affordable. So that's interesting. So eating more of these products will also safeguard the protein intake. You must combine it with the grains to have the full amino acid profile in the diet. So that's another recommendation that we have in our guidelines. But how much do we eat now? Well, that's only 7 to 8 grams a day on average. And we want people to eat 35 grams a day. So this is a major challenge for the Dutch. Many people don't consume pulses at all. They don't like it, or they haven't found ways to prepare them in a palatable way. We don't know, but something needs to change here to meet these guidelines. So, and the planetary health diet is even 75 grams a day, so even higher. Then we have another challenge, which I call the fish challenge. The planetary health diet allows for 30 grams a day, so it's always expressed per day. It doesn't mean you have to eat it every day, so it's just to make it uniform. The Dutch guidelines state 100 grams a week, which is 1 portion of fish, preferably oily fish, but also it should be sustainable fish. So in the Netherlands, we explicitly state sustainable farming and fishing in the guideline. And this is where you see how we could take the environmental impact into account into the guideline. This is not phrased explicitly in the planetary health diet, but we found it really important. And it's also interesting that the range of fish intake in the planetary health diet goes up to 100 grams a day, which is 700 grams a week, which we think might be quite a challenge from the sustainability aspect. And I would like to discuss that further with the Eat Lancet team. In the Netherlands, we do eat on average 15, 16 grams a day. However, that's not equally distributed. So half of the Dutch don't eat fish or only a little bit, less than once a week. So it's more a redistribution problem, but also the sustainability is a real challenge also, I think, for policymakers, how to make that known to people, what kind of fish they are eating when they buy it in the supermarket. So I don't see my discussion points, but maybe it's also good to mention one more thing, which is the just aspect of the Eat Lancet diet. How to bring that just aspect, the equity question, into the guidelines. That's still something we have to work on with the Health Council and others.
Okay, thank you. Okay, then Hanna van Zanten, Professor Hanna van Zanten is up next. She is full professor and chairholder of the Earth Systems and Global Change Group at Wageningen University and visiting professor at Cornell University. And Hanna's inter- and transdisciplinary research focuses on co-creating and assessing integrated solutions for food system transitions that respect human and planetary health. Wow, beautiful.
Thank you. Hi, yes, it's working. So, thank you, it's a great honor to be here today, and thank you for the introduction. So, Professor Rockström told you about the planetary boundaries and how the food system can actually help to stay, or make sure that we can stay within the planetary boundaries, but also its current impact. And that's exactly the starting point of the work I'm doing. So I focus on the question, how can we feed a growing population with enough healthy food while respecting the boundaries of our planet? Or in other words, how can we find integrated solutions that help the food system move towards this green area? And for that, we developed a model, which we call the Circular Food Systems Model, the CFOS model. So the CFOS model is a global model, and it's divided in different zones based on climate and soil conditions. So when it selects a certain crop, then different products are produced. We create crop residues, we create byproducts, but we also create human food. And part of this human food might be wasted. And we also create human excreta. All those different leftover streams can be recycled in the food system again, as a fertilizer, and part of them as feed for animals. So animals can also be fed with the grass, but also with other plant-based materials. And if we then produce animal source foods, we again create human food, of course, but we also create different leftover streams, such as manure and slaughter waste. And we can also make use of sustainable fisheries. So what makes this model unique is that it includes a lot of different feedback loops, circularity components. So for example, if we change our diet, then maybe the composition of the food waste is changing. Maybe, therefore, the composition of the animal feed is in fact changing. Therefore, maybe the composition of the manure is changing again. And therefore, maybe the composition of the fertilizers which we are using is changing again. And that might affect the model choice and which crops to produce which we are consuming. So all those cycles are actually connected to each other, which we take into account. And then, of course, I can show you many examples of a lot of different results, studies that we have been doing. And I would like to focus one on a global study and one more on a European level. So this is a study that we published in a special issue in the Lancet Planetary Health, which was led by Marianne Geleijnse, and a lot of the work that we did there was actually published, was used in the Eat Lancet 2025. So that is actually the integrated modeling assessment Professor Rockström was just talking about. And here I focus on the model study that we did. So we assumed a lot of things. And those are basically, you can see them as all solutions that form together integrated solutions. So first of all, we pushed our model towards staying within the planetary boundaries. And that is a major difference compared to a lot of the other models, because a lot of the models assume economic growth. We didn't prioritize that. We prioritized staying or pushing towards staying within the planetary boundaries, or the share of the food system at least. Then we followed the Lancet planetary diet. Then we had an assumption of a reduction of 50% in food loss and waste. But on top of that, we also assumed that the remaining waste was used as much as possible. Then we also allowed for a reduction in animal numbers, we allowed for diversification of cropping systems, and we followed current technology trends. So that also means an increase in crop yields, for example. And we optimized the food system for the environment. So what does that mean? That means, for example, that we not necessarily grow the crops where we have them today, but we might actually grow them somewhere else where the yields are higher. So if we combine all those things together, really all those things, then we found that we can stay within those planetary boundaries. And that's what you can see actually here. So this is the scenario where we combine everything, and then you can see total nitrogen use stays below, phosphorus use as well. And then I would like to highlight one thing, because I think that's where the model is most unique on its circularity component. So here in this last scenario that you can see here, you can see the total amount of waste which is produced and the total amount of waste which is then recycled. And you can see only a very small, tiny bit of difference. So that means that basically all the waste is recycled again. So we do not necessarily have waste in the food system anymore, but all the biomass got a certain function in its system. We did a similar assessment some years ago for Europe specifically, and what you can find is that this is the base. This is where we apply all those solutions together. You can see a massive reduction in greenhouse gas emissions, a massive reduction in agricultural land use. Honestly, this mainly comes from grasslands. Of course, this is a choice we can discuss later. And you can see that total protein intake largely reduced, but on top of that, the protein intake also shifts. So from where we mainly see actually animal proteins today, it shifts towards more plant-based proteins, as what Marianne also told you before. So I realized that this is a lot of changes, and it might not be the most realistic scenario. But I wanted to share this with you because it also shows that if we combine a lot of different solutions together, we can, in fact, stay within the planetary boundaries. But to also actually make sure that we create scenarios in co-creation, because at the end, what we do depends on what we as society want together. So for that, we developed a serious game which is connected to our food system model, which we play with different actors. I just come back from Uruguay, where we have been playing it with different food system actors. And this helps us understanding how people envision the food system in co-creation, and then quantifying this with a model and understanding where we want to go in the future. So also very happy if you're interested in this, please feel free to contact me. Thank you so much.